Harmonics, and welcome to today's episode of Innovations in Agriculture. In today's episode, I kind of wanted to geek out a little bit. I kind of wanted to get a little bit deeper into some technical, scientific, that kind of stuff. It's kind of interesting. If you've watched this show or if you watched some of my previous episodes, we kind of talk about different topics in agriculture, and um, obviously, in terms of current events, we're talking about fertilizer, we're talking about inputs, we're talking about how to save money, how to increase yield, how to reduce input costs, and all that stuff. And all of those different topics are, of course, very important. But today, it's a Friday. It's kind of the end of the day here with for us here. I know some guys on the West Coast. You guys are probably just wrapping up your afternoon, but if you guys are watching this live, just grab a frosty beverage, a nice cold glass of iced tea or a beer if you like, or whatever you might want. And I kind of wanted to educate you guys a little bit more on exactly what it is we do, but exactly the technology behind it. Because when you talk about innovations, there's two types of innovations, and this is an end to industry, but agriculture is no different. You have one type of innovation, which is what I call an incremental improvement, right? In other words, you're taking something that's already existing and already proven and already in practice, and you're just improving it a little bit. An example of that would be, let's say you take a combustible engine in a car, right? And over the last maybe 20 or 30 years, the combustible engine has been made more efficient through a lot of incremental or small improvements. Maybe a certain engine design helps generate more power. Maybe a different type of piston might actually be more efficient and actually help convert that fuel more efficiently into power for the engine as opposed to being wasted through heat. You have all these different things, and over time we have these incremental small changes, and those small changes can actually add up to quite a big difference. I mean, if you look at cars now here in 2020 that are being rolled out, even regular combustion engines, and you compare those to the cars that were produced in the 1980s or even the 1970s or the 1950s, you see dramatic improvements in the overall efficiency of that car design. However, all those different changes are small changes in and of themselves. Like a little bit of a tweak here, a little bit of a tweak there, a little bit of a tweak there, and over time, those changes become big differences. And agriculture has really been involved in a lot of those changes, right? You have small improvements in fertilizer usage, small improvements in soil amendments, small improvements in biological technology, improvements in technological stuff with the tractors and how tractors operate and how they're able to harvest things. Over time, there's a lot of changes through agriculture. And if you've been doing this for a long time, you've probably noticed quite a few changes. However, a lot of those changes are just incremental. They're small changes. In other words, they didn't completely revolutionize the way a tractor runs. They just continually improved that tractor over time and made continual improvements so that by now, you look 20, 30 years later, over maybe 10 or 20 different improvements over time, that the tractors now are way more efficient than they were 20 or 30 years ago, right? Um, but then, aside from just incremental improvements, you also have what I call big improvements, or sometimes game-changing innovations. Now, these types of innovations are large-scale, giant leaps forward. And to give you a few examples of these types of innovations, you look at the invention of electricity and the invention of the electric light bulb and how we transferred from gas lighting to electric light back in the late 19th centuries. With automobiles now, we have Tesla and other manufacturers that are producing electric cars and electric engines, right? Those are completely new ways of doing cars. They're completely new ways of transportation, right? They're not just incremental improvements to the combustion engine, they're a completely different type of engine, right? And those types of things are giant leaps forward, right? You can even look back in the 1990s and say GMOs back then may have been considered a giant leap forward in terms of that, but a lot of other types of agricultural practices are more incremental. So when we talk about the Kiminasi plant booster and using biophysics to stimulate, plant growth and plant health, we're not talking about a chemical input. We're not talking about a more efficient form of nitrogen fertilizer. We're talking about a completely different way to revolutionize the way we're considering how to improve productivity and health in terms of our continual production here. So today's episode, I want to go a little more in depth into how this technology it works, how it's a little bit different, and what the theory behind it is, so that you guys understand that yes, it is a completely different way of doing things, but you don't have to change the way you're farming dramatically. You just have to add this technology, and it will make everything that you're currently doing on your farm much more efficient, so that you get more productivity and better quality out of the existing inputs and agricultural practices. And then, of course, over time, as you start to notice these changes in your farm, you can make your own decisions as far as how you want to adjust your fertilizer or pesticide or other types of inputs. And we think, of course, that once you start seeing the results within the first year, you're going to dramatically rethink your fertility program, your crop protection program, and other programs that you've come to know and become used to, because now you're going to realize you don't need a lot of these inputs. You don't need to continue to do things in the old way. So without further ado, without further preamble, I'm going to share my screen here, and I want to start by sharing a video that we created. Actually, this was a couple of years ago when we first launched the Kiminasi Plant Booster. So this is not just this is going to take you back a couple of years if you guys have seen this. If you guys haven't seen this, this is kind of where we started when we launched this product, because we really understood that we needed to communicate this. And I'm going to start with how we were communicating this when we launched the product 2 years ago. And I'm going to then fast forward to maybe a few other analogies that might make it a little easier to kind of grasp exactly how this new technology works. But I thought it would be worth going back, because this really is, from the very beginning, a complete understanding of how this technology works. And then as I explain it, hopefully it'll make even more sense. So let's take a look here. Okay, so that was kind of what we came out with 3 years ago, and it's very interesting. As I continue to evolve the conversation, I've talked to many people. I've talked to hundreds of farmers, actually thousands of farmers now. I've talked to scientists. I've talked to agriculturists, agronomists, I've talked to PhDs, I've talked to everybody. Okay, I've talked to farmhands, I mean, everything in between. And as I continue to try to explain this technology and reference it in various ways, I, I've kind of evolved the explanation, but when I looked at this video recently, I realized that we already had a lot of the correct explanations that I have come up with all the way back when we first launched. It's just there's certain key points in this video that are very important to understand. If we can understand these key concepts, these two or three key concepts, you'll understand why this technology actually makes complete sense and why it's a matter of logic that this would work and this would produce tremendous results. It's not something that is illogical or irrational or seems crazy. It's actually when you understand a few key concepts, you'll understand that there's a complete rationality for this, and it makes complete sense why this would work. So I'm going to kind of highlight in this video a few examples here that I think would help an understanding of why this system is working as well as it does. The first key example is the Kiminasi technology, which is a biotechnology for life. Okay. In other words, technology as a word really just means we're taking scientific principles and applying them in an engineering sense to the real world. So, for example, when you have your cell phone, there's a lot of engineering and electrical engineering design concepts that go into the creation of that computer program that make up your cell phone, right? But from an applied standpoint, we're applying all that technology into a communication system, right? The computer that you're watching this on or that I'm creating this on is a piece of technology, but how we're applying this how we're applying the scientific principles of a computer program into a real world scenario is how that technology takes place. So biotechnology is really applying those laws of science, those laws of physics to a biological system. And of course, even chemistry can be considered a biotechnology in the sense that we're actually using nitrogen and phosphorus and other things. So these things are there. Um, the next thing I kind of wanted to discuss is going back here a little bit here. The plans, the life. This is Mr. Volvo Bamelli, the inventor of this technology, but I wanted to fast forward just a little bit here. Um, the concept here is a more energetic life. Okay. Now, when we look at living things, we look at biology, we look at physically living things, we look at human bodies, we look at plants, we look at living things, right? All life forms. We tend to think of them as being different than other things in and around us, right? We think of a being or living thing as different from a computer or a bottle or something like that, right? But living things, your bodies and the different processes in your body are still subject to biochemistry and biophysics. They're still subject to the laws of physics. And if you don't believe that your body is a part of the physical universe, then go jump off, go try to jump off a barn or a house or something like that and see how your body reacts when gravity grabs a hold of it and pulls it down to the ground. It is subject to the laws of physics, and everything that happens within your body is subject to the laws of physics as well. When you eat a hamburger, your body is digesting and breaking apart the different materials in that hamburger and extracting energy out of it. But all of those biological processes are based in the laws of physics and how those interactions take place and how that energy is transferred from the hamburger to your body, for example. And you have to understand that it's that chemistry. This is the other point that I wanted to explain here. Actually, I think it's here. Now, biophysics, again, the word biophysics simply means we're taking the laws of physics and applying it to biological systems, right? So we're enhancing biological systems through the laws of physics. But the real key point here is this is something that is right after this slide here. And this is key point. If we can understand this concept, I think it'll make a lot of sense. Okay. During his research, Mr. Baumelli has translated most of what is already scientifically known in the field of chemistry, right, into a biophysical language. In other words, if you look at how the chemical interactions in a plant, for example, how a plant utilizes, elemental nitrogen, right? We all know nitrogen, phosphorus, and potassium are all the three key minerals or nutrients that plants need, besides water and sunlight, obviously. Those are the key elements that a plant needs in order to grow, right? And so when we add fertilizer, we're paying attention to nitrogen, phosphorus, and potassium. Right? And carbon dioxide is absorbed through the plants through the air. And there's sometimes we will add other amendments like calcium and other things. But just generally, if you look at NPK, those three chemical elements that we use to fertilize the plants and give them the food that they need, um, is basically scientifically known in chemistry. In other words, we've already studied plant physiology, and we already know that the plants need those three elements, among others, in order for its biological system to work. Right? In order for it to produce the energy that it needs through photosynthesis, a plant needs nitrogen, phosphorus, potassium, and other minerals. Right? And that's all in the field of chemistry, right? All that research has been done for many and known for many years in the field of chemistry. So as we say here, Mr. Fulvio Bamelli translated everything that was already known in the field of chemistry. So all those interactions and the fertility programs and everything else, and he translated that into a biophysical language. And it was a language of physics that basically allows us to directly do the same things that you're doing with nitrogen, phosphorus, and potassium, but do them through the use of physics, right? In other words, when we look at the way a biological system interacts with nitrogen, phosphorus, potassium, carbon dioxide, etc., we can translate all those biological processes and those biochemical processes into the laws of physics, into a physics language. And that's exactly what Mr. Baumoli has done. So all we're really doing is removing the whole layer of chemistry, and we're translating it into a system of physics whereby we can actually take radio wave signals and directly stimulate the plant's interactions and improve those chemical interactions and make them more efficient. Now, again, this concept is a little bit different. It's a little bit challenging sometimes to understand exactly how radio waves and harmonics and these types of physical concepts in the field of physics would apply to a biological system. And of course, I can go through that, and I've talked to many scientists on this, but from a practical standpoint, the simplicity is all those chemical interactions that are happening in the plant, all those biological systems that are interacting in the plant, are all based upon how efficient the system is. And the system will be a lot more efficient if all of those biophysical signals in the plant itself are all harmonized to the frequencies that they should be. In other words, when all those systems are all aligned to each other and are all operating at the correct natural frequencies, that system will be very efficient and produce a lot of fruits and vegetables for us. When the systems become less efficient and become altered, then it doesn't matter how much nitrogen, phosphorus, or potassium we're putting into the soil. If the plants are not efficient at utilizing those nutrients, then you're going to be spending a lot of money on inputs and not getting the results you want at the end of the year. You're not going to see the plants generating a tremendous amount of fruits and vegetables just because you're adding more nitrogen to the system. And that's really the key concept. If we can understand how we can actually translate the laws of chemistry into the laws of physics, then all we're really saying is we're just taking everything that you're already doing and making it more efficient so that all the nitrogen, all the phosphorus, all the potassium, and everything else that you're using on your farm to stimulate plant growth is just going to get more efficient so that you don't have to use as much and you can get more yield on the other end. And the other side of it is it's very important. When can I get to this other slide here? In fact, biophysics approaches biological problems through the physical sciences. So, what is a biological problem? I mean, imagine, for example, a plant getting attacked by predatory insects, right? That's a biological problem. So, in nature, if a plant was healthy, it will change the physical properties of its leaves and of its cells in order to reject and cause the insects to avoid eating those plants, right? But in a normal system, a plant doesn't have enough energy because it's not producing the energy that it needs to make those biochemical changes happen. So our system, by making the whole energetic pathways of a plant more efficient, we're enabling the plants to solve its own biological problems. How do we produce more fruit? How do we produce better quality fruit? How do we have enough energy for insect resistance and fungus resistance and disease resistance? Well, you can handle this by using the laws of physics to make this entire biological system more efficient. And I'll get to the next part here. Now, Mr. Baumelli's technology develops through algorithms, which are sequences of instructions, right? And he's systematically calculated exactly how to make these plants more efficient. Okay, that's essentially what that's saying. He says these algorithms are made of wave packets. So in other words, there's a series of waves which we stimulate the water with, which correspond to the actual different biophysical signals. In other words, a plant has biophysical signals. In other words, a plant, as it's going through its process, will exhibit energy patterns based upon those biological systems, right? The biological processes. And so we've already measured what those biological systems should be like if the plant was healthy and producing good lots of fruits and vegetables. So we've actually promoted the vital processes of living beings, in this case, especially plants, in order to make them more efficient so that they can produce more fruits and vegetables with less effort and less inputs. And we do this in a non-invasive way, meaning we're not changing the genetics of the plant. We're not destroying the earth. We're not destroying the soil. We're actually just directly stimulating these plants in a non-invasive way. And I want to mention here because again, going back to one more thing here, back this is a key point. We're doing this for a more energetic life. One question that I get quite often from researchers, I get this from farmers, I get this from people of all walks of life, right? Is this concept that um, let me click here. That one back here. But this concept that how do we have one set of signals? How do we have one set of frequencies that cover all plants, right? Because obviously, when you look at a tree's metabolism is not the same as a corn plant metabolism, right? And a corn plant metabolism is not the same as an alfalfa plant or a flower or those types of things. So the question becomes, how do you actually do this? How do you have one set of instructions that covers all plants, or do you need separate instructions for each plant type? Now, the answer to that question, the key answer to that question is we're focusing on the bioenergetics of the plant. We're focused on the pathways that increase the plant's ability to generate energy through photosynthesis. And that particular process in plants is consistent across all plant varieties. Even though there's a few different types of photosynthesis, for example, C3, C4, and CAM, right? These are three different main types of photosynthesis. Those aspects of the differences in those different types of photosynthesis all have to do with how it utilizes carbon in terms of the process. For example, a C3 plant will take three molecules of carbon in creating the glucose chain that forms the energy pathway for the plant. A C4 plant, like a corn plant or whatever, will take four elements of carbon and bond them together in a different form of glucose. However, the whole process by which it's taking nitrogen, phosphorus, potassium, water, carbon dioxide, and utilizing the sunlight, the light side cycle of photosynthesis does not require, it's not a part of that Calvin cycle. In fact, the Calvin cycle, the second part of photosynthesis, is enhanced as well. It's just how those different types of plants bond carbon as part of creating that glucose molecule. And glucose is just a fancy word for sugar, and different forms of sugar that the plant creates when it's undergoing photosynthesis. So it doesn't necessarily matter what type of photosynthesis it is, but all plants will respond to one of those three types, and we have algorithms to improve and enhance all three of those types of photosynthesis. So in a nutshell, we don't have to worry about the fact that a tree's metabolism and how it produces cells or how it produces vegetative growth is different than, let's say, a flower or a microgreen. We don't have to worry about that because the energy pathways of those plants are the same. So all we're doing is maximizing and improving and enhancing the energy or metabolic processes of the plant so that the plant is more efficient. When you make the plant more efficient, all the other aspects of its biology will in tune be increased and improved as well, because everything in a plant or any living thing follows the metabolism of that thing. You know, the natural genetics of an organism, and if a plant is no different, will follow exactly how much energy that has. And the genetics of the plant will determine how that energy gets allocated throughout the organism. And plants are the same way. So all we have to really do and really focus on is how do we make that energy pathway super efficient so that you can utilize less inputs and yet get more yield and better quality as well. That's essentially in a nutshell what Kemonoxia Plant Booster does. We're producing tremendous results on farms all over the world. and all different types of crops, all different types of climates, all different types of soils, all of these other factors that all are considered wildly different and make everything very complicated are all junior in terms of energy production of the plant. When you can increase energy production is senior to all those other factors. So if you can increase the energy level of the plant, all those other factors will tend to work themselves out. So if you guys want to find out more specifically about the Kiminase Plant Booster, or if you guys really are interested in trying this on your farm, then please call me at 727 324 6750. You can see our website, it's been there. You can go to our website at harvestharmonics.com, but there's our phone number, 727 324 6750. You can also email us at service@harvestharmonics.com. Yeah, put that up there as well. So service@harvestharmonics.com. Feel free to contact us. We want to talk to you. We want to help as many farmers as we can because our mission, again, is to improve the quality of fruits and vegetables around the world. And the way we do that is by improving the farmer's ability to grow healthy crops without having to spend a fortune in getting it done. So if you guys want help, or if you want to improve your farm, or you want to be part of that next generation of farming that utilizes innovation in farming, then this is a key giant leap forward that you're going to want to take advantage of now, because if you wait 2 or 3 years till everybody else has already used this, then you're not going to get the same kinds of wins and competitive advantage that everybody else does. I hope to hear from you guys very soon. I want to wish you guys a very happy weekend, and we'll see you again next week. And hopefully, we'll hear from you guys soon and help you become part of the future of farming.